Good day everyone. Me and my groupmates will report about lighting. My part is from lighting to the key elements of efficient lighting design. The lighting industry has produced a number of alternative lighting systems. When designing a lighting plan, consult with knowledgeable professionals about optimum lighting levels and different types of fixtures and lamps. In addition to the purchase price, consider a long-term energy cost of fixtures before choosing any particular one. Energy-efficient lighting should be placed in areas of high continuous use such as kitchen, sitting areas, and outside the home. Use task or accent lighting for specific areas where greater illumination is desired rather than over-illuminating the entire room. Motion sensors, photo sensors, and timers should be part of the exterior lighting design. So kung magkuhan sa design sa atong lighting plan, so dapat ito magkuhan og professionals in order para sakto or makuha jud na to unsa dapat atong gamiton nga lamps or fixtures. Ang kaning fixtures is an electrical device used to create an artificial light by use of an electrical lamp. Yung example ani is under cabinet lighting, floor lamp, table lamp, and disc lamp. So then ang kaning light energy efficient lighting dapat gyud ibutang gid nato sa katong mga places atong balay or sa mga room sa atong balay, sa mga kad nga kinahanglan kay siya, for example sa kitchen, di ba kinahanglan gid ato perminting nga naay sa kitchen kay permi man ato gagamiton. Then outside sa home, then ang kaning mga motion sensors, photo sensors, and timers dapat maka part siya sa exterior lighting design. So some houses naa sila yung mga lamp nga naay sensor nga namusiga lang if ever nga naay tao, then mo-offer din siya nga iyaha lang. So daylight, bringing in natural light is an ideal way to increase comfort and aesthetics in a home while reducing energy consumption. Common examples include light tubes or light pipes, skylights, and clerestory windows. Careful consideration should be given to skylights and windows to avoid unwanted heat gains and losses. Light pipes can also protect the home from unwanted heat gains and losses associated with traditional windows. So dapat gyud ang atong mga balay, ang design sa atong mga balay is ato yung i-open siya or kanang magkuanta sa magamit gid nato ang natural light kay para pod maka-save ta og energy or to reduce energy consumption. So amo ni example sa clerestory windows. Ihang balay is kanang instead nga di ba nay ubad balay is close gig ayo, so bisan daytime ngitit kay lang balay, so ang kana siya nagkuan gid siya sa window nga glass lang, din ga hatag gid og kadang hayag sa iyang balay sa daytime. Then mo na example sa light pipe or light tube. Then mo na example sa skylights. Design of energy efficient lighting system. The aim of energy efficient lighting design is to provide the desired quality of light and other aesthetic properties of the light system with the least energy use. Design choices made for aesthetic reasons may in some cases reduce efficiency. For example, adding a diffuser to a luminaire to reduce glare will reduce luminaire efficacy. In other cases, these choices may improve efficiency. For example, lighting controls used to avoid the delivery of undesirable excess light are aesthetically preferable and save energy. So, ang kaning diffuser, kuha ni siya, translucent or semi-transparent cover that spreads out or scatters light. Using a diffuser will control brightness and give off a soft light relative to the lamp being used. They are typically made of glass or plastic and are used on the bottom or side of the light fixtures. They are typically used in offices or schools when there is a lower ceiling height. So, kanang naay example ani sa eskwelahan, kana bitang ang lamp is mura siya na cover, white iyang color nga pag-cover siya sa suga para iyang ma-minimize ang kahayag. Then para dili po siya sakit sa mata. The goal of energy efficient lighting design is to provide only as much artificial light as is desirable at locations where it is needed, when it is needed. The optimal system incorporates daylighting, provides proper illumination for design application, and reduces changes in occupancy. In the future, system may even modulate the spectral distribution throughout the day to improve human performance and well-being. So, ang goal sa energy efficient lighting design, para provide siya sa tuwa din, dapat yun, ikuan niya kung asa lang ang dapat nga location nga kinahanglan with og light or kanusa kinahanglan ang light. So the key elements of efficient lighting design are making maximum use of natural light. So tagaan gina to og kuan ang paggamit sa natural light. So for example sa atong mga balay, so tagaan gina to og lugar ang for example ang kanang sa maghakwanta sa atong mabalay og daghan window kay para sa daytime dili na to kinahanglan magamit og suga kay hayag naman atong sulod. Then using the most efficient artificial light technologies, so atong kuan gyud ang paggamit sa saktong suga, dili ta mag kuan tala-tala lang og gamit danang suga tungod kay ganahan to. So dapat ato gyud i-consider ang kanang mga suga nga kuan gyud og quality, din mupod ang appropriate nga gamiton. Incorporating automated lighting controls, so kuan pod maggamit pud ta ng mga suga nga naay mga sensor aron kuan makasave ta og energy, kay di ba usahay kung mag-on ta og suga usahay malimot tag palong. Then kung kung magamit ta og sensor, so dili na to bahalag malimot ta kay mo automatic ra siya palong og iya, so makasave gyud ta og energy. Then last is controlling high illumination task lighting separately from lower illumination ambient lighting. So ang kanang mga place sa atong balay nga dapat ang bisag walay light is hayag na siya, so dapat dili na ta magbutang og daghan kay suga didto kay dili naman siya needed. Okay lang kung gabi pero dapat gyud magbutang to suga, pero dili lang kay siya kanang daghan jud ayo sa para danang mga place nga dili gyud siya mahayagan. So ato gyud itagan og kuan ang katuraging mga place nga need jud siya butangan og mga suga. So that is the end of my report. Thank you.
Good day everyone. I am the reporter of Lighting Technologies. So as you can see, kanang sa right side mauna ang sample pictures sa incandescent lamp, which is an incandescent lamp produces light by passing an electric current through a conductive filament, which is heated by electrical resistance to the point of incandescent. So what is filament? So the filament is generally housed in a glass vessel or bulb that has been evacuated and typically filled with an inert gas. Incandescent lamp filament produce light whose spectrum is well approximated by a blackbody's spectrum. Kay ang typical incandescent lamps have operating temperatures at which the overwhelming majority of radiated power, so that typically is 90% or more, na mahulog siya sa infrared part of the spectrum, where it is sensed as na mas hayag iyang kainit or heat rather than visible light. So, incandescent lamps have warm color temperatures and excellent color rendering index. Ang incandescent lamp na siya init na temperatura and excellent color rendering index. Mas dali sila mahalap nga wala effect sa lab. Kay kung i-compare sa other lighting technologies, ang incandescent lamp kay dili gasto, gamay ug gaan, ug pwede magamit sa mas barato nga fixtures nga dili na gamitan og ballast or other controllers. And also, they also work equally well on AC ug DC power, ug dili na kinahanglan og high quality power input. The primary types of incandescent lamps. The first one is the general services lamps. So as you can see, sa right side, Mauna ang sample sa General Services lamps, or commonly known as the screw-in-A-type lamp, na gagamit og medium Edison E26 base. Kay kasagara sa mga standard incandescent lamp, kay dili kaayo makuhaan og light source nga kasagara makita sa mga balay. Long life lamps are an example of lamps which thicker, stronger filament than last much longer than a standard services lamp, but they are less energy efficient. Then the second is the reflector lamp. The reflector lamp are typically conical in shape with reflective coating na applied sa ibabaw sa bulb that has been specially contoured para makontrol ang direksyon sa light and distribution. So mo na siya ang kanang sa right side, mo na siyang example sa the General Services lamp nga E26 base and the reflector lamps, mo na siyang commonly nga atong makita. These are the common types of reflector lamp nga atong makita, included flood and spotlights, which are often used to illuminate outdoor areas, highlight indoor retail display and artwork, and improve the optical efficiency of track light and downlights. So mo ni siya ang kasagara nga atong mga makita nga common siya nga mga lamp. There are two types of reflector lamps: the parabolic aluminous reflector and ellipsoidal reflector lamps. The parabolic aluminous reflector are used for a number of applications, including outdoor flood lighting. So mo ni siya mga example sa mga parabolic aluminous reflector. And the second one is the ellipsoidal reflector lamps. The ellipsoidal reflector lamps focus light beams about 2 inches in front of its enclosure, projecting light down from recessed pictures. So mo ni siyang example pictures nga commonly nga atong makita sa parabolic aluminous reflector o sa ellipsoidal reflector lamps, which is this is the type of reflector lamp.
The halogen lamps to electronic ballast. These are the 3 examples of halogen lamp. So, what are they? The halogen light bulb or lamp is a type of incandescent lamp which uses a halogen gas in order to increase both light output and rated life. They are known for moderately high efficiency, quality of light, and high rated life compared to regular incandescent lamps. Where did they come from? The early story of halogen lamp parallels that of the incandescent. The usage of chlorine to prevent blackening of lamp was patented in 1882. In 1959, General Electric patented a commercially viable halogen lamp using iodine as the halogen gas. How do they work? A halogen lamp functions identically to an incandescent lamp, with one notable exception. The halogen cycle in a typical incandescent lamp, tungsten slowly evaporates from the burning filament. This causes blackening of the lamp, which decreases light output and reduces life. So, halogen lamps are largely able to eliminate this problem because the halogen gas reacts chemically with the evaporated tungsten to prevent it from affixing to the glass. Some tungsten is returned to the filament, which also serves to increase the rated life of the lamp because the temperature required for this reaction is higher than a typical incandescent bulb. Halogen lamps must generally be manufactured using quartz. So these are the steps of halogen lamp. So where are they used? First is this lamp, second is automotive lighting, third is kitchen lighting. So halogen lamps are used in variety of applications, both commercial and residential. Halogen lamps are used in automotive headlamps, under cabinet lighting, and work lights. In addition, halogen reflectors like MR and power lamps are often preferred for directed lighting such as spotlights and floodlights. They are also increasingly being used as more efficient alternative to incandescent reflectors. There are not many situations in which halogen lamps cannot be used, but one potential downside is the heat generated by halogen lamps, particularly in areas where HVAC costs are concerned. Electronic ballast. What is electronic ballast? An electronic ballast or electrical ballast is a device which controls the starting voltage and the operating currents of lighting devices. It does this through the principle of electrical gas discharge. An electronic ballast will convert power frequency to a very high frequency to initialize the gas discharge process in fluorescent lamps by controlling voltage across the lamp and current through the lamp. What does an electronic ballast do? An electronic ballast uses solid-state electronic circuitry to provide the proper starting and operating electrical conditions to power discharge lamps. An electronic ballast can be similar and lighter than a comparably rated magnetic one. Advantages and disadvantages. Electronic ballasts are more efficient and more compact in size and weight. They also provide the ability for continuous power adjustment and different settings. A disadvantage is that the power fluctuations may cause a failure, but this can be offset by adding a buffer capacitor. Operation of the ballast generate heat.
Fluorescent. A typical fluorescent lamp system consists of a lamp and electrical regulating ballast. The lamp is comprised of a glass tube, two electrodes, and a lamp base. The glass tube contains low pressure megavolts and the inside gas, which is usually argon, and a phosphorus coating on the inside of a tube, which determine the light spectrum of the fluorescent lamp and thus its correlated color temperature or CCT and CRI. Fluorescent ballast. A fluorescent ballast provides the necessary voltage to start and maintain the arc in the lamp tube because the electrical resistance of a plasma goes down as its temperature increases, and a ballast is required to regulate the electric current through the lamp. So there are the two types of fluorescent ballast. First is magnetic ballast and electronic ballast. So these are the type of fluorescent ballast. First is magnetic ballast, operate at electric power system frequency. Second is electronic ballast, operate a higher frequency and have many advantages over magnetic ballast. These are include higher efficiency, the ability to drive multiple lamps in series or parallel, lower weight, reduced lamp flicker, and quicker operation. These characteristics, as well as regulatory measures, have led to the phase out of most types of magnetic fluorescent ballast. These are typical starting method for electronic ballast. There are instant start. First is rapid start and program start. An instant start ballast use a high voltage to strike the arc of the lamp. As usual, instant start ballasts are very energy efficient but are more appropriate for application with less frequent switching cycle like on-off. Fluorescent lamp, linear fluorescent lamp or fluorescent tube are typically categorized by on their tube diameter. So these are the type of linear fluorescent lamp. The T12. T12 are 1.5-inch diameter fluorescent tube. These are the oldest of the fluorescent tube and they almost always run off magnetic ballast, which are no longer manufactured. So typically you see T12 in troffers. Sometimes you find T12 in older warehouse or older hallway in apartment complex. High output T12 are also found in signage. T8 are 1-inch diameter fluorescent tube and they are the most prevalent of all fluorescent tube. 4-foot TAs in particular are used everywhere in hospital, commercial, office space, schools, retail space, and warehouse, and everywhere. Are most efficient, expensive, and produce a lot of light. Typically, you find T8s in trougher. However, you also see them in strip light, some highly bright fixtures, and sometimes you find them in more specialty applications like cove lighting. Rarely, they are used in decorative application. T5 are the smallest tubes that are 5/8 of an inch diameter. These are the newest development in the fluorescent family. Although they are the smallest, they are the most energy efficient and brightness. In fact, some teas last of 1900 hours. Because of their energy efficient and light output, you see a light of high output. Teas used in warehouse fixtures. You also see them in over-the-counter light, self-lighting or job lighting in retail space because of their compact size. Plasma lighting. Plasma lamps emit light via plasma discharge, emission from electrically excited gases contained within an arc tube. A typical lamp's design consists of a ballast, igniter, electrodes, and alumina, glass arc tube filled with pressurized gases and lamp base. The most common plasma lamps are mercury vapor, high-pressure sodium, and metal halide. These are classified as low-pressure sodium. Lamps are also plasma lamps and are often ground together with HID. Since they are high lumen output technologies used in similar applications, exterior and large interior commercial and industrial spaces, LPCS lamp technology is not discussed in depth, as it is an older technology that constitutes a very small fractions for commercial and residential markets. EV lamps, first developed in 1901, used ionized mercury as the primary discharge element, producing a bluish light with better CRI than sodium lamps, but with relatively low efficacy. Phosphors can be used to improve the color and CRI of EV lamps. Relatively blue light, but they yield relatively poor color rendering compared to other HID technologies. HPS lamps and LPS lamps both utilize mixtures of ionized sodium and mercury gases, and this difference in pressure leads to continued light quality characteristics. So LPS lamps offer the highest efficacy, but the monochromatic condition of the light spectra reduces the visual acuity and mesopic relatively low light condition, thus reducing the effectiveness of the light in the outdoor application. And then MH lamps are similar to MV lamps, but MH gases are added to the mercury gas and the discharge tube, yielding higher lumen output and efficacy with higher CRI. Improvements in the starting technology of MH lamps have had considerable effect on lamp quality. A new HID technology known as light-emitting plasma uses induction starting to excite the gas vapors instead of an electrical discharge. This electrodeless induction lamp utilizes field gases that are similar to those in MH lamps but uses a solid-state radio frequency driver to excite the gases inside the lamp. Light-emitting plasma or LEP also has dimming functionality that could allow for significant energy saving compared to other HID technologies. So actually, a plasma lighting systems are electrodeless metal halide lamps that produce light directly from an R discharge operated under high pressure. And then plasma is a form of matter. Also simply a gas of a separated changes, typically ions and electrons, which behaves as an electromagnetically coupled fluid.
Good day everyone, my name is Marlon Atabay. Now I'm going to present or report about the solid-state lighting, LED and OLED. Ang solid-state lighting kay usa ka klase nga suga nga nagamit og semiconductor light-emitting diodes or LEDs and organic light-emitting diodes or OLED. Mao ni ang sources sa suga kaysa sa mga filament sa elektrisidad, plasma. Actually gigamit ni sa arc lamp sama sa fluorescent lamp or gas. Ang mga LED ug OLED gihimo ang elektrisidad nga mahimong makitid nga band nga suga pinaagi sa emisyon sa diode ug makahimo og lain-laing mga wavelength gikan sa infrared pinaagi sa makita nga spectrum hangtod ultraviolet. Ang mga LED naglangkob sa usa ka semiconducting die kasagaran usa ka porma sa silicon ug germanium, usa ka circuit board ug usa ka lens o diffuser. Sa pipila ka mga kaso gigamit usab ang mga phosphor ug heat sink depende sa aplikasyon ug gitinguha nga light output. Ang mga OLED naglangkob sa daghang lain-laing mga organikong light-emitting compound, electrode, usa ka sagad nga transparent, ug kasagaran usa ka plastic o glass nga envelope nga nagkupot sa tanan nga mga sangkap sa lugar ug naglihok ingon usa ka lens o diffuser alang sa unit. Mao ni ang advantages sa LED or light-emitting diode kumpara sa mga gigamit nga teknolohiya sa suga kauban ang mga mosunod. Una, taas nga pagka-epektibo nga miresulta sa labing mubo nga gasto sa operasyon, taas nga mga kinabuhi nga dunay gireport nga mga kantidad sa kinabuhi nga 30,000 ka oras ug mga tagna hangtod sa 50,000 ka oras nga nagpaubos sa tinuig nga gasto sa siklo sa kinabuhi. Panduha, gipaayo ang pagpaandar sa mga aplikasyon nga ubos ang temperatura tungod kay ang mga LED labi ka epesyente sa mas ubos nga temperatura. Pantulo, dimmability nga adunay katugbang nga mga dimmer nga gilaraw aron magtrabaho kauban ang mga LED driver. Pangupat, kahanas sa pag-tune sa mga color sa teknolohiya sa pagsagol sa color. Mauni ang disadvantages sa LED o light emitting diode kumpara sa mga gigamit nga teknolohiya adunay kauban ang mga mosunod. Una, taas ang una nga gasto bisan ang mga presyo sa LED dali kaayong nahulog. Panduha, mga pagbag-o sa temperatura sa kolor sa paglabay sa panahon. Pangtulo, mga issue sa pagdumala sa init. Ang mga LED lifetime ug efficacies na minusan pag-ayo kung mag-operate sa taas nga temperatura. Gilimitahan ang ilang abilidad nga gamiton sa nakita nga fixtures. Pang-upat, dili pagkauyon sa mga inconvenient dimmer. Ang mga dimmer nga nagpalihok pinaagi sa pagbag-o sa linya sa inconvenient nga linya sa usa ka lead na lampara o aparato kanunay nga dili molihok nga maayo sa mga lead lamp. Panglima, ang mga problema sa pagkutkot sa pipila ka mga lampara nga lead, labi na kung dili na modulom. Pang-unom, taas nga pagsidlak tungod sa siksik nga kinaiyahan sa mga lead packages, bisan kung kini masulbad pinaagi sa paggamit sa usa ka diffuser. Ang mga ulid nagamit usa ka nipis nga film sa mga organikong materyales aron makapagawa sa lain-laing kahayag sa usa ka planar nga surface. Gigamit kini nga labi na alang sa pagpakita sa mga laing dikurente sama sa mga smartphone, apan adunay potensyal alang sa kinatibuk-an na mga aplikasyon sa suga sa niche, labi na ang pagsabwag sa suga. Ang pinaka-main nga kalainan tali sa ulids ug LEDs mao ang porma nga hinungdan. Ang paagi nga giapod-apod ang light emission naghimo ang OLED nga medyo nagkatag nga suga sa daghang lugar kung itandi sa kusog nga intensity nga makuhaan sa suga nga gihatag sa usa ka lead. Karon ang OLED naa sa luyo sa lead sa daghang mga sukdanan sa paghimo kaniadtong 2012. Ang labi ka maayong gi-report nga mga epektibo alang sa OLED mga 60 lm or W ang paghatag sa color sa OLED, kay maayo sa pinakamaayo nga adunay mga CRI hangtod sa 95. Bisan pa ang kinabuhi sa usa ka OLED maura ang 10,000 ka oras og sensitibo kaayo sila sa kaumog o kainit. Kinahanglan nga pag-amping ang proseso sa pagmanupaktura aron matarong nga masilyuhan ang mga ulid o ang ilang kinabuhi gipamubo nga mahinungdan. Next reporter, Miss Crystal Arcibal.
Lightning Control is an intelligent network-based lightning control solution that incorporates communication between various system inputs and outputs that related to lightning control with the use of one or more central computing devices. Lightning control are widely used on both indoor and outdoor lighting or commercial, industrial, and residential spaces. Manual controls are controls that are manually performed by individuals. It is a simple strategy providing users the capability of choosing light levels either in step or over a wide range with smooth transitions between levels. Sensor-based control is a device that detects the change in the environment and responds to some output in the other system. The role of sensor in a control and automatic system is to detect and measure some physical effect, providing the information to the control system. These are the examples of light sensors. Occupancy sensors is an electronic device that detects the presence of a person that are automatically control the lights or temperature or ventilation systems.
Passive infrared, PIR, and ultrasonic sensors. PIR sensors typically have two slots in them, each of which is capable of detecting IR radiation. As a warm object, human passes in front of one detector. A positive pulse is generated, and as it moves past the second detector window, a negative pulse is generated. This represents movement, and using relatively simple analog electronics based upon a pair of operational amplifiers, a signal is generated to signify the presence of a moving warm body. Often, an optical IR filter is fitted to the front of the sensor to limit the wavelengths to those of interest. The IR energy from a human body is around 10 ohm, for example. The area that a PIR detector is able to cover is a function of its placement in the room as well as the lens that is typically fitted over the sensing element. In many cases, this will be a Fresnel type of lens, often made from semi-opaque plastic, that concentrates IR radiation from a wide area onto the sensor. An alternative approach is to use ultrasonic transducers to detect people present within a building. This uses sound waves at a frequency higher than humans are able to hear, typically in the range 30 kHz to 10 mHz. Transducers comprise a pair of devices. One is a transmitter and one is a receiver. A sound pulse is sent out at a given frequency, and as it bounces off objects in its path, it is reflected and captured by the receiver. In an empty room, the reflections will come from the opposite wall, and the time taken from the reflection to be received will be proportional to the distance between the transducer and the wall. When a human enters in the room, then the pulses will reflect from them, and as they are closer than the wall, the time taken to receive the reflections will be less. These types of systems are known as time-of-flight or TOF systems. As for a given medium such as air, the sound waves travel at a constant speed, meaning that the object distance can be detected by knowing the time taken for the sound pulse to be received. Both PIR and ultrasonic detection can be used in standalone systems and connected systems, principally to detect the presence of humans, but there are other applications as well. Lighting control is a key part of many BEM systems that sense the presence of people and control lighting so that it is only on when needed. PIR sensors can be used for this, but they do require the person to be moving. On the other hand, ultrasonic sensors can scan an empty room and then know when one or more people are present. As part of a more sophisticated BEM, this information can be used to control and automate heating, ventilation, and air conditioning HVAC systems to save energy and minimize environmental impact. PIR are very commonly used in security or intrusion detection system in both domestic and commercial applications. As they are placed away from the potential point of entry, door or window, they will detect any intruder before they are able to reach the sensor and tamper with it. Connected robots are becoming more popular in both domestic and commercial applications. In the home, simple robots can vacuum rooms unattended, while similar technology is increasingly being used for robotic lawn mowers. Objects in the path of these robots are an issue, and ultrasonic transducers are commonly used to detect these obstructions and change the direction of travel. In industrial applications such as large factories and warehouses, robots are used to move goods from one place to another. While these automated guided vehicles or AGVs may be intended to run in defined paths that should be free objects, almost all AGVs use ultrasonic transducers to detect other AGVs and objects that have inadvertently been left in their path. The application of this non-contact distance sensing technology are many and varied. For example, it is common to embed ultrasonic sensors in tanks to measure the level of liquids. This is equally applicable to domestic heating oil tanks as it is to large tanks of chemicals in process industries. In the connected world of the LOT level, information could be used to drive a system that manages auto-replenishment. PIR sensors detect occupants' presence by sensing the difference between heat emitted by moving people and background heat. Ultrasonic sensors detect the presence of people by sending out ultrasonic sound waves into a space and measuring the speed at which they return.
Photosensors and schedule controls. Photosensors, daylight responsive control, also called daylight harvesting, uses a light sensor also called a photosensor or photocell, with a power controller to switch or dim lighting in response to available daylight. As light levels rise above a target threshold due to daylight contribution, the photosensor signals the control to reduce light output, thereby saving energy. According to Lawrence Berkeley National Laboratory or LBNL, daylight responsive control can generate 20% average lighting energy savings. This strategy is highly suitable for lighting zones adjacent to windows and clerestories and under skylights and roof monitors, anywhere daylight is concise and plentiful. Photosensor can be used to prevent outdoor lights from operating during daylight hours. This can help save energy because you don't have to remember to turn off your outdoor lights. Photosensors sense ambient light conditions, making them useful for all types of outdoor lighting. These light-sensitive controls are less effective inside the home because lighting needs vary with occupant activity rather than ambient lighting levels. Many LED night lights, however, have this feature built in which makes them effective and easy to use. Scheduled controls. Scheduled controls adjust light levels according to predetermined schedule. It adjusts the output of the lighting system based on the time event implemented using time clock, which may be implemented using a microprocessor built into the control system. At certain times, controlled lights will turn on, off, or dim to either save energy or support changing space functions. Scheduling is highly suitable for larger open spaces that are regularly occupied as well as spaces that are intermittently occupied but where the lights must remain on all day for safety for security reasons. Local override, time extension, wall controls are often used to allow for irregular use of the space. Occupancy-based strategies lumping together time scheduling with occupancy sensing can realize 20% average lighting energy savings, according to Lawrence Curley National Laboratory or LBNL. Schedule controls. Scheduling adjusts the output of the lighting system based on the time event implemented using a time clock, which may be implemented a microprocessor built into control system. At certain times, controlled lights will on, off, or dim to either save energy or support changing space functions. Lighting scheduler was purposely built for appointment data models, allow deeper and more granular resource control.